Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is one MCQ about the reaction of dibromo compound. You can see the dibromo compound here. So you have to say what is the major product of this reaction, and here student look at 4 options are provided and one of them is the right answer. I request you student, please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as your explanation. But don't hesitate student whether your answer will be right or wrong. Remember, self-evaluation is essential for improvement, and that's why you should try. I believe you have tried by yourself, so it's my turn to give you the right answer. So I suggest you student, please look at this molecule again. So this is actually vinyl bromide, this part. So this part is vinyl bromide, and the another part, this part is allyl bromide. So their reactivity is different, and another is it's a carbon-carbon double bond. And the first step of reagent is alkyl magnesium bromide RMgX or Grignard reagent. Student, just look at the first step and this reaction. We know Grignard reagent can act as either base or it can act as nucleophile. So just look at this first step and this. So where the nucleophilic attack is better? Obviously in this allylic position, because we know allylic halides or allyl bromide can undergo SN2 reaction better, and in this case bromine is also a good leaving group. Second thing, since the penta coordinated transition state is in conjugation with this double bond alkene, so it is stabilized. So SN2 reaction on allyl position is highly favored, although this vinyl position is not possible. Okay, so that's why first step reaction will happen here. So you can see via SN2 type of reaction mechanism, these carbon negative attacks here, because Grignard reagent is nothing but a carbon ion in nature, so it will leave and ultimately it will produce these vinyl bromide derivative. Now we know this carbon, actually one information you students you should know that this vinyl halide bond, mean this Br, this bond is relatively stable, this vinyl bond. Why? Because there are 3 lone pair of bromine which can make a conjugation, so it can push and it can open. So in conjugation it can produce, this is the bromo, this is the minus, this is the plus. So from this you can understand the carbon halogen bond, this vinyl carbon bond is more than single bond, so it's actually partial double bond character it has. So that's why this bond is pretty stronger. That's why during nucleophilic substitution using Grignard, this bond was not broken, although the activated bond of this carbon bromine bond got broken and carbon carbon bond is produced, means this bond. Now in the next step what happens student? Sodium amide in mineral oil heated with 150 degrees centigrade. So it is pretty drastic condition, because we know these amide are very strong base. So what they do here, actually they are base and they abstract this proton. There are actually 2 protons, so they abstract this proton. So this negative charge abstract this proton, it pushes, it leaves. So in this way at first what it produces? It produces this C6H11, fine, and attached with, so this is carbon triple bond carbon hydrogen. So it is produced actually an terminal alkene, but in this context there is a twist. What? See, in this reaction this bond is actually sp hybridized carbon hydrogen bond, and it is pretty acidic, and in presence of this very strong base and higher drastic condition, this proton got abstracted and reaction actually ends up here, means this acid terminal as alkynes carbon ion or acetylide derivative formation. And later on upon workup it produces this terminal alkyne. Here an important point you should remember student, that whenever this terminal alkyne will be produced, instantly it will react with base and produce this carbon ion. So theoretically greater than 2 equivalent of base is essential to make the reaction complete. Okay, so we need greater than 2 equivalent of sodamide as base, because first step, first equivalent will be used here for this proton abstraction, and second equivalent will be used this proton abstraction, and this second proton is more acidic because it is sp bond, whereas if you look at this, in this case if you look at this bond, this proton, it is actually sp2ch bond. Okay, and we know that acid base reactions are the fastest, so that's why reaction will ultimately end up here, and this makes the reaction or the equilibrium to proceed in the forward direction, this anion formation. So if you look at the key step and name reaction associated process is, the first step is the Grignard reagent is acting as nucleophile to produce this CC bond. Second reaction, this sodamide act as base, and ultimately in expense of more than 2 equivalent of base, it produces the salt of this terminal alkyne. Later on, upon workup, means retreatment or reaction with water, it produces the terminal alkyne. This is because if you look at this water molecule, this is delta plus and this is delta minus, and in this case this carbon ion abstract this proton and generate the base. So in this way this terminal alkyne with this H is produced. Okay, so in this case what is the right answer? The right answer is terminal alkyne, fine. So option B is the right answer. Now if this question appear in your exam less than 30 seconds, how can you come up the right answer? Okay, so for that purpose you need to understand that this is vinyl bromide, sp2 carbon bromine bonds relatively more stronger, and this is allyl bromide, this is very activated for nucleophilic attack. And in this case what is given? This methyl magnesium bromide. Okay, so acid base reaction is not possible because no that much acidic proton are there, but nucleophilic attack possible, and here also one allyl halide or allyl bromide is given which is activated for SN2 type reaction. So that thing if you understand that, okay, obviously cyclohexyl attachment will happen, point number 1. And in this case I suggest to student, please write the intermediate product, and it will make your life easier. So write this, and if you write this second sodamide mineral 150 vinyl bromide, so terminal alkyne will be the product undoubtedly. So in this case what is the product? Obviously option D, terminal alkyne. Only one option about terminal alkyne given, there is option B. So this option B is the right answer. Okay, so in conclusion what you have learned today, that Grignard reagent can act as both base and nucleophile, and this is due to the negative charge concentration on carbon atom. In this case here you can say both aliphatic and aromatic Grignard, same thing, same type of property you can expect. Here the alkyl halides are susceptible to undergo nucleophilic substitution or SN2 reaction due to the stabilization of pentacoordinate intermediate by conjugation with the pi, means carbon-carbon double bond. So that's why these allyl halides are activated or susceptible for SN2 type reaction. Fine. Now in this case the vinyl bromides can produce alkyne by the treatment of very strong base, but in this case huge but, that if you are trying to prepare terminal alkyne, then you need 2 equivalent. Okay, so you can see this terminal alkyne can react with strong base like sodamide and potassium tertiary butoxide etc., and it produces acetylide salt, and due to the relatively enhanced stability of this acetylide salt it's produced because this deprotonation happens on the sp-CH bond. Okay, and remember that these step is responsible for selective terminal alkyne preparation, and that's why no alene is produced as intermediate. Okay, so this is the end of discussion. I believe this video may be useful. Please write your opinion in the comment box, and if you really consider the content of this channel is worthy, then please help this channel to grow. Thanks for watching. See you in my next video. Bye bye. Take care.